Okay, I hope I'm audible to all my students who are attending this particular lecture for the introductory econometrics course. In this particular lecture, I'm going to start with the discussion of the 2024 question paper, which has come up at Delhi University for the introductory econometrics course. And this lecture is recommended for all those students who are pursuing economics honors from University of Delhi. Now, all students can see the 2024 question paper on your screens. Okay, so in this particular lecture, I'm going to start with the discussion of question one, which is a question based on statements, which we have to see whether they are true or false statements. Okay, so let's quickly start with the discussion of question number one in this particular lecture. So let's look at question one, part A. Okay, we need to see whether these following statements are true or false, and we need to also give reasons for our answer. So for an OLS estimated regression equation, yi hat is equal to b1 plus b2 xi. Students can see this is nothing but the sample regression function, SRF. The sum of the product of the residuals and the mean deviation of the explanatory variable is 0. So what do I need to show? The sum of product of the residuals are denoted by EI, and mean deviation of the explanatory variable. Mean deviation means deviation of xi from its mean. I need to show that this is equal to 0. Okay, so let me quickly come to the whiteboard to solve this. So I'm just writing the main heading for completeness. This is Delhi University Exam 2024. Name of the course is Introductory Econometrics. This lecture is recommended particularly for students who are pursuing BA Honors Economics from University of. If you are pursuing a BA program course and you have introductory econometrics, you can still watch this lecture to gain knowledge about the kind of questions which come up in the Delhi University exam. But particularly the lecture is focused for economics honors students. Okay. So we are looking at question one, part A. What do I need to show? I need to show that summation, the sum of product of the residuals with the deviation of xi from the mean is 0. So we have done this proof in our lectures on linear regression. If students have subscribed to my complete course for introductory econometrics course, you will find all the proofs I cover in my lectures on linear regression. Okay, so if I consider the left hand side, which is summation ei times xi minus x bar. If I open up the brackets, this is summation ei xi minus summation ei x bar. Okay, this I can write as summation ei xi. X bar is a constant, it comes out of the summation times summation ei. And recall from my lectures on linear regression, the linear regression module. The access for this will be given to all those students who have subscribed to my complete course for introductory econometrics. Okay, so recall from my lectures on linear regression that summation ei xi is equal to 0. We get this from the second normal equation. This is nothing but the second normal equation. Second normal equation when we do the OLS procedure. Second normal equation for the OLS procedure. OLS means ordinary least squares. Okay. Remember from my lectures on linear regression, when we conduct OLS procedure, our objective is to minimize summation ei square or minimize the residual sum of squares. So when you look at the second normal equation we get by conducting the OLS procedure, we get summation ei xi equal to 0 and summation ei is also 0. Again, I've shown this in my lectures on linear regression that the sum of all the residuals is 0. So what I'm trying to say is that this is also 0 and this is also 0. This is equal to 0. This is also equal to 0. So I can say that my whole expression will be 0 minus x bar into 0, which is 0, which is equal to the right hand side. So I have shown that summation EI times xi minus x bar is equal to 0. Okay, summation EI is equal to 0 from the first normal equation. I am writing it. First normal equation. This is the first normal equation for the OLS procedure. Now, obviously, in this lecture, I'm not conducting the whole OLS procedure. It is meant for all the students who have subscribed to my complete course for Introductory Econometrics. Okay, but if you look at the first normal equation, it gives you summation EI equal to 0. If you solve for the second normal equation, which I have already done in my lectures, you get summation EIXI equal to 0. You plug them, you get LHS exactly equal to RHS, which is your answer. That means this statement is true. Statement is true. My first statement is true. So if I come back to the question paper, this is a true statement. I have shown that for the OLS estimated regression, the sum of the product of the residuals and mean deviation of the explanatory variables is 0. Part B, ceteris paribus, that means keeping all other things constant, keeping all of the factors constant. Higher the variance inflation factor, smaller is the variance of OLS estimators. Now, students can recall my lectures on multiple regression. Students who have subscribed to my complete course, please rewatch or revise my lectures on multiple regression, where I've discussed in detail about the variance inflation factor. And students can also find this in my lectures on multicollinearity. Multiple regression and multicollinearity. In both these lectures, you can find the discussion of variance inflation factor. Particularly, you will find this in my lectures on multicollinearity. If you watch my lecture on multicollinearity, I've discussed variance inflation factor. Okay, so if I come to the whiteboard, erasing all this off, question 1 part B. Okay, now consider the sample regression function. Consider the sample regression function, also called SRF, which is as follows: yi hat is equal to b1 plus b2 x2i plus b3 x3i. Okay, and recall from my lectures on multicollinearity. Recall from my lectures on multicollinearity that variance of B2 formula was sigma square over summation small x2i square times 1 minus r2 square. Okay, and variance of B3 was sigma square over summation small x3i square times 1 minus r2 square, where x2i, where small x2i, I can write, where small x2i is capital X2i minus x2i bar, x2 bar, let me write myself x2 bar, and small x3i is capital X3i minus x3 bar. So x2i represents deviation of capital X2i from its mean. Small x3i represents deviation of capital X3i from its mean. Okay, and what is R2 star? I can write here that R2 star is the correlation between R2 star is the correlation between X2 and X3. R2 star is the correlation between X2 and X3. I have covered all this in my lectures on multicollinearity. Okay, and on the top I can write what is my variance inflation factor. Define the variance inflation factor as which I call as VIF, as follows. The variance inflation factor is 1 over 1 minus R2 square. So I can write this as sigma square over summation small x2 I square times 1 over times the variance inflation factor. Let me correct myself. Because 1 minus R2 square, I can write this as 1 over 1 minus R2 square, which is my variance inflation factor. And similarly, guys, this I can write as sigma square over summation small x3 I square times variance inflation factor. Because look at the definition of variance inflation factor from the top. It's just 1 over 1 minus R2 square, where R2 square is the correlation coefficient between x2 and x3 for a multiple regression. Okay, so I can say that variance of DE2 is just sigma square over summation small x2 I square times variance inflation factor. Variance of B3 is sigma square over summation small x3 I square times the variance inflation factor. Now students can clearly see that as, so clearly, let me call this as equation 1 and equation 2. From equation 1 and 2, we see that as variance inflation factor increases, it implies variance of B2 also increases and variance of B3 also increases. That means the variances are going to increase as variance inflation factor increases. But look at what the statement was telling us. If I come back to the question paper, higher the variance inflation factor, smaller the variances. False. Statement B is false because I've shown that higher the variance inflation factor, higher the variances of the OLS estimators. So I can say that statement B is false. I can write here statement B is false. Because we have learned that higher the variance inflation factor in both the cases, higher will be the variances of B2 and B3. Okay, so coming back to the question paper, let's look at part C. For an OLS estimated regression equation, yi hat equals b1 plus b2 xi, is a sample regression function given to us. If we multiply both y and x by 1000 and re-estimate the two regression models, the intercept coefficient will also increase by 1000 times. Now, students can check out my lectures on functional forms for this, where we have discussed in depth what happens if I multiply the variables or the coefficients, how will the transform regression look like. So students who have subscribed to my complete course for introductory econometrics, you will find similar kind of questions I've done in my lectures on functional forms. So let me come to the whiteboard to solve this. So this is question 1 part C. Okay, so we are given that yi hat is equal to b1 plus b2 xi. We are given this sample regression function. Okay, and in general, I can say that let yi star be equal to 1000 times yi and let xi star be equal to 1000 times xi. Okay, so yi star is basically 1000 times yi hat. I multiply yi by 1000. I also multiply xi by 1000. Now, will the coefficient, will B2 change? So let's figure that out. So I can write basically that yi, my transformed regression. Let us see what will happen to B2 star and B1 star. Now remember from my lecture that B2 star is not affected by change of origin and scale. Okay, the formula for B2 from the OLS students should be able to recall it summation xi minus x bar times yi minus y bar over summation xi minus x bar square. Okay, so which I can also write as covariance of xy over variance of x. Now, guys, what is this? This is change of scale. Change of origin means when I add a constant to the variables. Change of scale means when I multiply a constant to both the variables. And we know from the statistics course, we all know from the statistics course, we know that covariance of xy is not affected. Covariance of xy is affected by change of scale. Covariance of xy is affected by change of scale. Variance of x is affected by change of scale, but their ratio is not affected by change of scale. But the ratio covariance xy over variance x will be unaffected by change of scale. Will be unaffected by change of scale. So if I look at numerator over denominator, covariance of xy is affected by change of scale. That means covariance of xy will be 1000 times the initial covariance. Variance of xy will also be affected. That means if I look at the ratio of covariance of xy to variance of x, that will be unaffected by change of scale. So I can say therefore B2 star will be equal to B2. Since B2 is unaffected by change of scale. B2 is unaffected by change of scale. I have done this in my lectures on linear regression as well. Okay, if you look at B2, it is unaffected by change of scale because B2 after all is covariance of xy over variance of x. Numerator is affected by change of scale, denominator is affected by change of scale, but their ratio is not affected by change of scale. So the ratio is B2, which is not affected by change of scale. So even if I multiply y and x by 1000, B2 star and B2 will remain the same. But what about B1? Now from the OLS procedure, what do we get as B1? If I erase all this off, I can write that B1 star from the OLS procedure is y bar star minus B2 star x bar star. This is what we get from OLS, from ordinary least squares procedure. B1 star will just be y. This is how we calculate B1, right? In general, B1 is just y bar minus B2 x bar. So B1 star will be y bar star minus B2 star x bar star. Now, how much is y bar star? Y bar star will be 1000 times y bar minus B2 star times x bar star will be how much? X bar star will be 1000 times x bar. I'm writing it here. Y bar star is just 1000 times the original y bar and x bar star will be just 1000 times the original x bar. Remember, mean is affected by change of scale. Mean is affected by change of scale. So if I multiply x bar by 1000, the new mean x bar star will be 1000 times x bar. Mean is affected by change of scale, I can write. Okay, so and guys, B2 star is just equal to B2, so I can write 1000 times y bar minus B2 1000 times x bar. Now I can take 1000 common. I can take 1000 as common, so I get y bar minus B2 x bar. And what is y bar minus B2 x bar? Just B1. So guys, I've shown that B1 star, I've shown that B1 star will be 1000 times. I'm repeating the process again. By OLS procedure, B1 star will be y bar star minus B2 star x bar star. Y bar star is 1000 times original y bar. X bar star is 1000 times original x star. I have shown that B2 star is equal to B2. Within this, I take 1000 common. Inside, I get y bar minus B2 x bar, which is nothing but my original B1. So I have shown that my new B1 is 1000 times the original B1. So I can say that my intercept coefficient, remember B1 denotes the intercept coefficient. The intercept coefficient will be 1000 times the original intercept. So I can write, I can erase this particular part and I can write that the new intercept coefficient, B1 star will be 1000 times the original intercept coefficient. 1000 times the original intercept coefficient B1. And B2 star will exactly be equal to the original slope coefficient B2. Remember guys, I'm repeating it again, B1 always denotes the intercept and B2 denotes the slope in my lectures as well. So when I multiply yi and xi by 1000, there will be no change in the slope coefficient, but my new intercept coefficient will be 1000 times the original intercept. So if I come back to the white lecture, the intercept coefficient will increase by 1000 times, true. So statement C is true because I've shown that the intercept coefficient B1 star will be 1000 times B1. So hoping students have understood this. So I stop in this particular lecture. We have solved question 1 parts A, B and C in this particular lecture. In the next lecture, I'm going to start with the discussion of question 1 part B. So I hope all students have enjoyed this particular lecture. Okay, to subscribe to my complete course for introductory econometrics, please get in touch with me on WhatsApp. I can guide you about how to buy my complete course for Delhi University Introductory Econometrics course. Okay, any doubts in this particular lecture, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. Okay, this is where I stop in this particular lecture.